So reflections. Last year we only had a reflection in the x-axis because you only had a reflection with the y. You never had a negative with the x. This year you're going to have both. So remember I told you these 3 lessons you're going to have to know extremely well because the 4th lesson is putting them all together. And if you don't know them extremely well, when I put them together, then you're just like guessing. And guessing is a problem. Why? Because all the common errors of your guessing are answers. Okay, so you're not going to be able to like narrow it down and be like, oh, it must be this one. It's not going to happen. Your common errors will be there. Okay? So this one says the graph of y equals x squared minus 4x plus 4 is shown. Write the equation of y equals negative f of x. So what I want you to do is go to your calculator. In your calculator, I want you to type in x squared minus 4x plus 4. In y equals, aka the graphing thing. Oh. You're putting the equation in. All right. So you're going to go x squared plus, minus 4x plus 4. And then you can press zoom 6 just in case your window's been changed crazy. Zoom 6 gets you back to the negative 10, 10, 10, 10 window. So instead of you changing it, zoom 6 lets you change it. Okay? Now, what we want to do is we want to find that minimum because we want accuracy, right? Off the table of values, if you go second graph, there's the table of values. Those are all the points that are on your graph. But what we need to do always is we want to be able to find the minimum just in case, because what if the minimum is a decimal? Will you find it on this table? If it's a decimal x, no. There can be decimal y's, but all of your x's are integers on this table. Okay? Now, if you're someone who pushes the button to see how long the table will last, don't. It keeps going forever. Now, I knew it was you. So if you want to get back to 1 and 0 and that, you're going to have to hold the button the same amount of time to get back. Or I'm going to show you how you can do something. So you can go second, and you can go to table set. Behind here, it says table. So you want to go to that. And you can go table start, and I have -1, and it's up by 1s. Okay? If you wanted it to go up by 0.5s, you could put it up by 0.5s, because this is change in. It's a delta, right? Change in the table. Okay, and so you could put -1 here, so at least you can move back if you're at 1,000 or something crazy because you were just holding it down to prove a point. It will keep going. Okay, we're good? So in my table, I only have integers, correct? And even if I put 0.5s, that still doesn't cover every decimal under the sun, does it? No. So I want to find a minimum. So I'm going to go second, trace, and you learned this all last year. This is a refresher course. It's a minimum because it's the lowest part of the quadratic, right? There's the highest part. If it's a hill, you would climb up the hill, you're at the top. You're at the maximum that hill can be. If it's a valley, you climb down to the bottom of the valley. It's the minimum you can be, right? Unless you have a shovel, you're not getting any lower. Okay, so we have a minimum. So we're going to press 3. Or you're going to go down, arrow down, press enter. But 3 works just as fine. So I'm going to go 3. Okay, now it says left bound. Whenever it says left bound, you have to be left bound of whatever the heck you're finding. Left bound isn't always consistently the same thing. Left bound is just always what we're finding, right? So we're finding the minimum here, this right here. So I need to be on the left of it. I can be anywhere on the left. I can be higher up, I can be lower down, but I need to be on the left of it. Okay, left bound, anywhere on the left, hit enter. Then it says right bound. Oops, let's go away. So then I need to be anywhere on the right of what I'm finding. I'm finding the minimum. So anywhere over here, I could go higher. I could go all the way up here if I really wanted to. I just need to be on the right. Hit enter. And then you have to hit enter so that it guesses. And it's at 2, and this is why I wanted to show you this. So people will tell me my minimum's at 2 and 1.1. 1.1 e to the -12 means that's like times 10 to the -12. Okay, it's scientific notation. So what it actually is 0 decimal 11 zeros, 1 1. So 0.00000000000000, what could I round that to? 0. It was 0.00000. Okay? So our minimum is actually at 2 and 0. So if you have like e to the negative 10 or e to the negative 9 or e to the negative 7, that's just 0. Okay? It's 0 with a whole bunch of zeros and then a number, which we're going to round to 0. So you always have to check for this so that you don't accidentally plot 1.1. Plus, you know that this isn't at 1.1. It would be higher if it was at 1.1. Okay, so we're going to plot 2 and 0. Yeah, boss. If I see a phone, I will take it from you and ruin your phone life. Put away your... I'm recording this. I forgot I was. Okay. Second table. Okay. Oops. Okay. We're supposed to be on both sides of the 2. I might just record period 4 as well. We'll see how that goes. So we're on both sides of the 2. We're on both sides of the 2. So I'm going to go to 2. And it happens to be 2 and zeros on here because it was a whole number, correct? Not a decimal. So I'm going to pick values on both sides to plot it. So I have 1, 1. I have 0 and 4. Then I'm going to stop because the next one will be off. And then I'm going to go this way. I have 3 and 1, 4 and 4. Oops. Let's pretend it actually is going through there. So that's my original point. We agree? Now, f of x equals this, correct? They want us to write the equation of negative of the whole of f of x. We agree? So that would be y equals negative, and what's f of x actually? Minus 4x plus 4. So in brackets, I have x squared minus 4x plus 4, which is actually the same as negative x squared plus 4x minus 4. We agree? So we're going to go into our y equals to 2. Leave the first one in. Now everyone pay attention if you don't have the colored ones, because a lot of people didn't know this, and I didn't know they didn't know this till this year, really. We need to type into our calculator the way we speak. So if we say negative, we have to press the negative button. If we say subtraction, we have to press the subtraction. If you mess them up, it will give you a different graph. Okay? So it's negative x squared plus 4x minus 4. Now paying attention, if you have the colored ones, you're going to have different colors. Yay. If you don't have the colored options, what I always do is I make my second one thicker. Now I'm going to forewarn you, when we press the button, there are other options other than thicker. Please continue to pay attention after you find the thicker one. Don't go pressing the other options to see what they look like and then not listen to me for the next 5 minutes and have no idea what I'm talking about. Okay? Okay. So we're going to arrow over to this little line over here. You can actually go over there if you didn't know you can. You can. And you can hit enter once and it makes it thicker. So now you know that when it draws the graph, instead of drawing 2 graphs, and you know that they draw them in order, which is true, right? But then you go to read your question and you come back and you're like, uh-oh, which one was which now? Because they're drawn and they're there and you can't see them, right? So now you'll know that the thicker one is the second one. I always make the thicker one the second one. So now I know that's the second one, right? I can go off, do my question, come back, and I still know that's the second one. Okay? We agree? All right. So let's plot that one. Well, that one looks like this. And then I go, now to read this table, these are the points of the second table, here and here. And then this here and this here are the points of the first graph, right? This is y1, it's the first graph. The x's stay the same. So I have 0 and negative 4 now. I have 1 and negative 1 now. I have 3 and negative 1, and I have 4 and negative 4. What happened to my graph? There's a reflection in the what axis? The x. So when you have a negative in front of the f, that's actually not with the x, right? If it was with the x, it's in this bracket. That's the only thing that's with the x, is anything in the bracket. We agree? Is this with it? No, it's in front of it. So if we have y equals negative f of x, or if they have the negative with the y equals f of x, either way, because why? I can divide this negative 1 over, and it's going to be negative 1 f of x. We agree? Yeah? What happens when we have that? We have a reflection in the x-axis. We had a reflection in the x-axis in grade 11. The only reflection we didn't have in grade 11 was a reflection in the y-axis. Where do you think the negative is going to be when we have a reflection in the y? With the x's. What changed between this graph and this graph? What part of the coordinate changed, the x or the y? The y. The y's all became what? Negative, right? So remember when we did mapping yesterday, it was really easy. Anything with the x went mapping with the x, anything with the y went mapping with the y. We agree? Same thing here. If it's not in the bracket with the x, it affects the y variable of your mapping. If it's in the bracket with the x, it affects the x variable. It's really, really easy. Okay? So if you don't know what it should affect, if it reflects in the x, the only way I can reflect in the x is I'm either down and I reflect up, or I'm up and I reflect down. What's changing? The y's, right? So if you can't remember which one to multiply by, just think about it. Don't memorize. Memorize scares me, because what if you memorize wrong or you forget your memorization? Understand. Understand makes 30-1 a heck of a lot better. So if you have a reflection in the x-axis, it's your y's that are negating, correct? So if you forget, don't memorize. Think about it. Okay, I have a reflection in the x. What's changing? Oh, my y's are all being negative. So if I was down here, I would negative a negative, which would actually make it positive, right? That's how it reflects. Yeah? Invariant points are points that do not change. Very important. They ask for these. Points, also known as coordinates, that do not change. Okay? When you have just a reflection in the x-axis, have you guys ever done this as a kid? Or yesterday? I don't know. Maybe you did it yesterday. When you walk up to, have you ever walked up to a mirror, usually in your bathroom or whatever, and you have something and you push it against the mirror and it directly reflects in the mirror? Like when you put it right against the mirror? You're looking at me like you've never done this. Do you know what I mean? So if you take an object like my daughters do, toothpaste or their toothbrush, and you push it right against, it reflects in the mirror, does it not? What point doesn't change? The part that's directly touching the mirror. It doesn't change, right? What's the mirror in this case? The x-axis. So where's my invariant points going to be? So if I have more things, say I have actual translations up or down, will it always be on the x-axis then? No, because then it would move the graph around. But if all I have is a reflection in the x-axis, my invariant points are on the x-axis. Okay? So if you only have a reflection in the x-axis, your invariant points are on the x-axis. So what would the invariant point be for this graph? 2, 0. That one. Yep. How does the graph of y equals negative f of x compare to the graph of y equals f of x? What is it? It's a reflection in the x-axis. If it reflects in the x-axis, it affects the y's. If it reflects in the y-axis, what do you think it's going to affect? The x's. Okay. So we have reflection in the x-axis. So our mapping, if we just have this, our mapping is going to be x, y becomes x and what? Negative y. Huh. Okay? That's why I said practice makes this better. The more you practice, the better you'll be. Okay. So we have to sketch the graph of y equals negative f of x. If we're sketching a graph, what did I tell you to do? Use mapping, because you're moving points or coordinates. And if you move points or coordinates, use mapping. Now, like I said to you now, this is easy now, but it won't stay that way, right? So our mapping is xy becomes what? Because we have a negative in front of the f of x. X negative y. So I'll fill in one point to prove it, but after that you don't have to fill in every point. However, once we start putting a whole bunch of transformations together, mapping is extremely essential, and I put in every single point so that I don't make a mistake. So I'm going to pick some points that are important. So this one's important because it's my maximum, and then I need a point on the arms. So I'm going to pick that one and that one. Okay, so I have negative 3 and 1. What's it going to become? Negative 3 and negative 1. Does it look like it's reflected in the x-axis? This point is now here? Yeah. And then we have negative 1 and 4. It's going to be negative 1 and negative 4. So the x stays the same. No, I've changed. And then I have 1 and 0. And it's going to stay 1 and 0, because if I multiply 0 by negative 1, it stays the same. That's why they are invariant, right? You're multiplying by 0. So would I have actually had to look at this one at all? Or this one? No, because they are what? Invariant, because they're on the x-axis. So note to self. So sometimes it won't ask you for what the invariant point is. It'll ask you how many invariant points there are. So they could give you any graph like this on the diploma. They could go, I didn't like it, it needed to keep going. Okay, and I say of the form y equals negative f of x, which is actually illegal because this isn't a function. Why is this not a function? It doesn't pass the vertical line test. If I draw a vertical line through here, it crosses in more than one spot. So I would actually have to make it not as nasty looking. So there we go. Okay. Now if I ask you number of invariant points, do I even need to draw the new graph? No. So we have a reflection in the x-axis. So anything that's on the x-axis stays the same. We agree? So how many of them are there? Place in the first box of numeric response, or whatever, right? And they can ask another one. They could say this now, because we're going to go into this right away. What if they said y equals f of negative x? And they ask for the number of invariants. It's a reflection in the what, do you think? It's a reflection in the y. So where do you think the invariant points are going to be on? On the y-axis, because that's going to be your new mirror, right? So how many would there be? 1. I just answered this question that fast and because I knew what I was talking about. So math is great and also scary, because if you forget little things like this, the question is impossible, or you're drawing the whole thing and wasting your time, right? But if you know this, that's a really fast question. Okay? All right. So here's the next one. We're going to graph that original one again. So it was at 2, 0, 1, 1, 3, 1, 0, 4, 4, 4. All right. So in this case, this is function notation, right? The last one, it was in front of the f of x and we distributed it in, correct? Do you remember function notation from grade 10? If I gave you, it is. Okay, so when we did function notation, say we had f of x equals x plus 3. We agree? What in grade 10, what if we did this? F of 3. What would we do? What are they just telling you? X is 3, right? That's all they're saying. So it would be 3 plus 3, and it would be 6. We agree? That was grade 10. It was a rough year. It's real hard. A lot of people, that takes like a whole lesson, guys. Okay? Yes. Okay. So, well, no, it's because it's brand new. You've never seen function notation until grade 10. That's why. Okay, and you throw some variables in there, which makes it harder, right? Okay, this one here is f of negative x. So what are we saying? Instead of 3 goes in for x, we're saying negative, what is this? Negative x. Negative x goes in for x. Okay? So our equation is this. So we're going to go, this equals negative x. So for each of these x's, I'm going to fill in negative x. Instead of 3 or instead of m or instead of a, I'm filling in negative x. So I'm going to get negative x squared minus 4 times negative x plus 4. So I get negative x squared is positive x squared. Negative 4 times positive, or negative 4 times negative x is positive 4x plus 4. We agree? Okay, go to your y2, clear out the old one, put this one in. A little slidey. So I clear it. When I clear it, my thick line goes away, so I'll have to go back to that. So x squared plus 4x plus 4. If I wanted to punch into my calculator, could I punch it in like this? Negative x squared minus 4 times negative x plus 4. Same graph, right? Just more options to put in, but same graph. Okay? When we press graph, it should reflect in the x. So if we reflect in the x, this negative, or this 2, 0 is going to become negative 2, 0. This 1, 1 is going to become negative 1, 1. What am I changing? The x's are being negated and the y's are staying the same, because has anything affected the y's? Is there anything outside the bracket with the x? No, so only x's are changing. If it's in with the x, it affects the x. If it's outside the x bracket, it affects the y's. Always. Doesn't change. So what's the coordinate of the invariant point in this case? Which one didn't change? Right. So it's always on the y-axis where it doesn't change, correct? Because that's where our reflection is. That's the mirror. Like if you were the little kid who went up to the mirror and put a paper up, the paper would reflect completely in it, and the only thing that wouldn't change is the edge of the paper that was against it. You wouldn't be able to see it because it's right against it. How does the graph of y equals negative x, compare to the graph of y equals f of x? It's going to be a reflection in the what? The y-axis. You need to practice these because it's always a reflection in the opposite axis of what it changes, right? So it's a reflection in the y-axis, and it has to be a reflection in the y-axis because if the x's are being negated, any x over here on the right is going to now be on, or on your left, I guess, is now going to be on the right, and anything on the right is going to be on the left if it's a reflection in the y-axis. Yes? So practice, practice, practice. So this one we're going to reflect in the x. So our coordinate mapping is going to be xy becomes negative xy. So if we use our points again, we have, these are the points I used last time. Negative 3, 1. and negative 1, 4, and 1, 0. This is going to become 3, 1. This is going to become 1, 4. Bless you. Bless you. And this is going to become negative 1, 0. And the one that's going to stay is the y-axis. So this one I can instantly put a spot on it. That one I can instantly put a dot, correct? Because it's invariant. This goes here. This goes here. Then this goes. And if you look, the mirror is the y-axis, right? Kind of. Very symmetrical mountain. Okay. Shh. Okay, I want you guys to draw this one in one color and this one in another color. You can do however you want. If you need to do like dashed lines and dotted lines or triangles. I have highlighters you can use too. All right. So for y equals negative f of x, that's a reflection in the what? X-axis, which means it affects the, it always affects the y variable because it's not in the bracket, right? So our point is going to be xy is going to become x negative y. So all the y's being negated. So this one's going to stay the same. So people will tell me this one has 2 invariant points because these are the only 2 bolded ones. Is this not on the x-axis as well? Yeah, so how many invariant points does this one have for this particular equation? 3, right? Since it's not bolded doesn't mean it's not invariant. So this one is at 1, 2, 3, 4, negative 4 and 1, 2, 3, 4, 5, 6. So it's going to be at negative 4 and negative 6. Then I connect them. Go to the next one. This one's at negative 1 and 6, so it's going to be at negative 1 and negative 6. The x's are staying the same, the y's are changing. 2, 3, 4. So this one's at 0 and 4. It's going to be at 0 and negative 4. This one is at 4 and negative 3. It's going to be at 4 and positive 3. And then we cut back down. You'll have a graph that you're going to just draw on. Like you can draw all over the test, right? And then that's why a lot of people like printing these notes off, because then you have the graph to actually physically draw on. Y equals f of negative x is what? A reflection in the? So it affects the x. So xy becomes negative xy. So all the x are being negated and the y's are staying the same. So this one is at 1, 2, 3, 4, 5. Negative 6 and 0. So it's going to be at 1, 2, 3, 4, 5, 6 and 0. This one is at 1, 2, 3, 4, and 6. So negative 4 and 6. So it's going to be at positive 4 and 6. Then I connect them. Oh, poorly. Connect them. And then this one's at negative 1 and 6. It's going to be at positive 1 and 6. This is invariant. Why? It stays the same because it's on the reflection, right? And then this one is at 1, 2, 3, 4, and negative 3. So it's going to be at negative 4 and negative 3. And then this one's at 1, 2, 3, 4, 5, 6, 7. So it's going to be at negative 7. Yeah? The graph drawn in the thick line is the reflection of the graph drawn in the thin line. So we're going to say that the Thin line is f of x for both cases. Write the equation for each graph drawn in the thick line. So this thick line is what type of reflection as opposed to the thin one? Is it a reflection on the x or a reflection on the y? X. Where's the invariant point? On the x. It's on the x, it reflects in the x. If it reflects in the x, it affects the y. So we're going to get y equals, do we get negative f of x or f of negative x? Because what variables is it affecting? The y. So it's not going to be in here because anything in this bracket affects the x variables. This one has an invariant point on the y-axis, so it affects the x. So we're going to get y equals f of negative x. Write the equation of the image of y equals 10x after a reflection in the y-axis. If it's a reflection in the y-axis, it's reflecting in the y. What variable am I affecting? X, because if it was positive x, it would now be negative. I'm affecting the x. So if I affect the x, I have to be with the x. So it's going to be y equals 10 to the negative x. This one is a reflection in the x-axis. In order to reflect in the x-axis, I can be up and go down, or I can be down and go up. But what am I changing? The y's. So if I change the y's, am I with the x in the variable? No. Only thing that changes the x is in that bracket with the x. So this x is going to just stay x. You can put the negative with the y and then move it over. You know it's under that radical because it doesn't change the x's. Okay? Like I said, these lessons alone are not too bad. Put them all together, and if you don't know these lessons well, that is scary. Let's look at example 9. If the negative is here, where would you put the negative on the given y equals square root x minus 2? So you would put it in this case, do I need a bracket? No, because there's nothing behind it. But what if it had something like this? So this one says there's a reflection in the y-axis. If there's a reflection in the y-axis, it affects the what? X. So we're going to get y equals, this x is going to be replaced with what? Negative x. Does anything else get replaced? No. Now, negative x squared is just x. We agree? These are the same. How's that even possible? The graph has a vertex at 0 and 1. And then it does this. It's symmetrical about the y-axis. So if I reflect this arm here, it's going to be over here. And if I reflect this red arm over here, it's going to be over here. And you actually have the exact same graph. So if your graph is symmetrical about your reflection, it's going to stay the exact same graph, right? And that's why these actually end up being the same, even though we did take the negative of the x. Is the y going to be the same? It's like this. It's now going to be like that. Is my graph and my equation going to be the same? No, my equation is going to be for a graph like that, right? So if we have a reflection in the x-axis, that means we have a negative in front of the equation. We agree? Please pay attention. People do not do this on the diploma all the time. They write it like this. This is wrong. This is bad. What did we? Yeah, we need brackets. Remember what we did with the very first one where it was x squared minus 4x plus 4? We put the negative in front with the brackets and we distributed the negative in because it affects everything. This doesn't even make sense. Yes, it's downwards, but it's downwards with a vertex at 0 and 1. So it would actually be this. Is that a reflection in the x-axis? No, that's wrong. So we have to go y equals negative the whole thing and apply it. Everyone forgets that. They don't apply it to the y. This is your y-intercept at the back. They don't apply it to the y-intercept. And I promise you, this will be there and picked more often than this one. I had people come out of the diploma, I remember 2 years ago, and they were like, that question was on and I only remembered to do it when I got out. And I was like, well, that's too late. So don't be that person. Remember to distribute it in, okay? If you have an equation that has transformations already, it has to apply to the transformations because it didn't make sense if it didn't. If we had that +1 here, the graph wouldn't be correct, right? But now negative x squared minus 1, I have a vertex at negative 1 and 1, and it goes down. I love doing that. There's joys in some things. Yeah, take the bad. Just want this bad one because it's so bad. Yeah. I did it once by accident. It was super fun. It'll bounce. If you, probably. It's not nearly as bad as my singing was a few seconds ago. But like if you do. Oh, I don't want to send those away. Come on. Click. You guys are jealous right now, aren't you? It's fun. Oh, I think it's like, no, you're done now. Whoocha! So that's your homework. No idea what this is. Oh, wow. I have layers. Oh, oh, oh. Whoa. I was just having fun. Don't mind it. I wanted to be able to throw more things. Oh, there, I got it to bounce. I don't know how you get it. See it. Oh, let's try it. No, I don't believe you. Oh, you were correct. Oh, I'm still recording.